Welcome to a second episode of my engineering Oddcast on the subject of AI. Today we're going to look in a bit more depth at whether AI can do the job of being a software engineer and whether AI can do the job of being a programmer. So I said in the last episode that I thought an AI system with an appropriate system prompt might actually be able to do a good job of the engineering interview if it were interviewed by a non-engineer. I thought I would dig into that a bit more and in fact try and find a system prompt that would let it pass an engineering interview even when it is given by an engineer. I won't drag out the suspense. I was unable to find a system prompt that caused it to behave in a way that would convince me it would do a good job of engineering. But I think it's interesting and perhaps instructive to look at the question that I asked and what the response was. So I told the AI that it was to behave as a principal engineer having a conversation with a business analyst. So I would play the business analyst here. I didn't say how senior the business analyst was, although in this scenario, if anyone asks, it's actually a relatively junior business analyst. I'll read you the problem as I gave it to the AI. And at the end of that, I will say, that's where the prompt ends and give you a chance to, if you want to pause this broadcast and think about what you would do with it. The exact way I phrased it to the LLM is as follows. Here is the scenario. We have an 80 gig file composed of fixed length 1K records. These records are not sorted. We have 20 gigs of free disk space on the machine. The total disk size is 100 gigs. The disk is a hard disk, not an SSD. We have 10 gigs of available RAM on the machine. It is not possible to add more RAM or more storage. It is not possible to allow any records to leave this machine. It is not necessary to preserve the original file. We have a function that tells us if one record is logically less than another. We have capacity to run up to 4 threads of compute. Describe a process which results in us having a file containing all the records which are in the file we start with in sorted order. That's the end of the prompt. If you want to pause now and ask yourself, how would you respond to that in an interview situation? Now's the time to do it. So, welcome back to any of you who paused, and for those of you who didn't, I'm glad you're still here. The correct response to this for an engineer is to realize that the question is really not adequately specified and to identify what you would need to ask in order to reduce it to something that is adequately specified. If your instinct was to sit down and work out an algorithm which solves what you think the problem I asked you to solve is, then you have done the same thing as the AI assistants all did, which is try to come up with a solution. But you have failed this interview unless I was interviewing you for a junior engineer position. And frankly, I wouldn't ask this question to a junior engineer because it's way above their pay grade. If you're a senior engineer or you're going to pass the interview as a senior engineer, there's questions you should ask, like, this scenario's weird for 2025, like 80 gigs is not that much data. Why have I only got 10 gigs of RAM? Why have I only got capability to run 4 threads? Why is it on a hard disk? Why are we unable to add memory? Why are we unable to add storage? Why are we unable to move the data off the device? In the interview context, I have explanations for why all of these things are how they are. Meeting a junior business analyst for the first time, you shouldn't assume that they have truly found the scope of the problem. You should always ask, like, hold on, this is an odd situation. Like, why is this constraint there? Because can't and it's not possible. Like, it is possible to add RAM to things. It is possible to add storage to things, like in the general case. So specifically, what's the barrier here stopping us from making this problem much easier? Because at some point, that becomes part of the engineering conversation. If the barrier to giving you more storage is easier to fix than solving the algorithmic problem, you should just do that, not solve the algorithmic problem. The other reason that you've failed this test, if you try to actually solve it as stated, is engineering is a process of finding an optimum solution. But nowhere in that scenario did I tell you what we were trying to optimize for. And there are very, very different answers if I tell you that we're trying to optimize for simplicity of code so that we can be sure before running it that it's going to work, or if I tell you to optimize for elapsed time, or if I tell you we need to optimize for minimum disk IOs. And the other thing that was not stated in the question and that you really need to know before trying to produce an optimal solution is it necessary to preserve the integrity of the complete set of records so that records don't become duplicated or lost if there's some kind of machine failure during the runtime of the process. And you really should need to know that before you start trying to work out a strategy here, because the best strategy, if you don't need to preserve the records, is probably a lot different to the best strategy if you do need to preserve the records, because of the nature of how those how that constraint affects what you must do. So I asked a bunch of AIs. The one that gave me the best answer was a 32 billion parameter model of questions with QWhen. So I gave it the maximum context size. It took a great deal of time to run on my machine, but this is an unquantized model running on a mix of CPU and GPU on my biggest computer. That was the only one that gave me the best answer, and it didn't appear to get confused or start forgetting things. The simpler models that don't have an internal monologue or dialogue to reason with couldn't answer this question at all beyond mumble merge sort, which is not an acceptable answer. I also did try DeepSeek R1, but the only version of that I can run on my machine is heavily quantized, and I was reading its thought process as it was trying to reason through the question, and I was seeing a lot of there's a kind of very hard to describe, but there's a characteristic look to quantization errors that are introduced when an LLM is quantized down, and I was seeing that happen in the thought process in a way that was affecting the result. I don't want to tell you that DeepSeek R1 was worse than QWQ for this problem, because I wasn't able to test the actual real model of DeepSeek R1. I will say that one that was comparably quantized down so that it could run in a comparable amount of resource to QWQ was worse than QWQ. It also means I can't say that a state-of-the-art reasoning AI like DeepSeek R1 couldn't have solved this problem better than QWQ did. I have to tell you that I wasn't able to test it due to not having powerful enough machine in my own possession. Let's talk about how you should respond to this kind of problem if you were to encounter it in the real world at various levels. And bear in mind that if I were using this as an interview question, I would have said, look, let's pretend that we're in this scenario for real, and I'd just tell me, what you would do, behave as if you were talking to the business analyst. Arguably, the correct thing for a principal engineer to do with this problem is to say, well, look, I wouldn't meet with the business analyst. I'd get one of my senior engineers who I trust to ask the right questions to go and talk to the business analyst about this, and I'd brief them and say, like, the scenario here seems odd. Can you find out for me, why are all these things that are sort of out of time or slightly weird? Why are they the case? What's the real constraint there, and at least do we need to keep the data, and then also tell me your thoughts on how you might address it after you've done that. That is probably what you should do if you had this problem given to you as a principal engineer, assuming that you've got a senior engineer who you trust to be able to do those things, who isn't busy at doing something more important. If you're actually doing this yourself as a principal engineer, then your response and what a senior engineer should do are actually the same thing. And as I say, you need to probe into why all these constraints are there. And also, do you need to be able to make sure if there's a power failure and the system recovers, that you are able to do that without the loss or duplication of records. So you need to know that. Another thing you should ask is, are there going to be big clusters of them that compare equal to each other? Or is it much more likely that the records are all different? You should find out, how much of that 1 kilobyte of data is actually used in the sorting process, and if it's a fixed part of it, how many bits is it? There's a whole host of other things you should find out, some of which depend on the answers to the earlier questions. But for example, you could also go down the line of the data's on a hard disk. Okay, how's that attached to the machine? Because the performance behavior of that, if it's actually it's part of a SAN array and there's a 4 terabyte DRAM cache on the front of that, and we're going to run this at a time when no one else is really using that SAN volume, then the fact that it's a hard disk is basically irrelevant. You're really talking to DRAM and its bus speed that's going to be a limit, but you no longer in that scenario need to really worry about doing random accesses anymore, because they will be as fast as sequential ones. Conversely, if it's directly attached on something like Serial 88 or more likely SAS or another such local bus, then you've got to concern yourself with things like seek times. But that's, those are things you should consider finding out. Now, it's not the case that if you just ask questions, you're going to pass this interview, because I will, at random-ish points, ask you, why are you asking that question, to check that you're asking it for a good reason. And, ideally that you'd be able to say, well, look, if it were this scenario, I'd lean this way. If it were this scenario, I'd lean this way. If it's something else, then I'll be excited to, hear of another possibility I haven't already conceived of, and I'll think of a suitable plan. So those are all that information gathering part is one of the things I want to see. Let's now progress to a part where you have got enough information that designing a system to solve it is reasonable, and I will tell you the answers that the AI has inferred the situation, so that you can try and design with the same constraints that it chose for itself. Okay, so it's chosen to assume that you really can't add more RAM, you can't add more storage. It chose to assume that you do not need to be able to preserve all the records in the case of a failure, so it's assumed the machine will not fail during this process, or that we can at least restore the original file unsorted and go again in that scenario, and that's acceptable. That's the assumption it's chosen to make. It's chosen to accept as true the constraint you can't allow records to leave the machine. It has chosen to assume that the hard disk is indeed locally attached, and so it does concern itself with seek times and so forth. It's chosen to assume that the original file is stored in sequential blocks on disk, so that sequential reads of the original file will be fast. And it's chosen also to assume that it's important that the resulting sorted file is part of is able to be read in one sequential chunk. Now, I'm going to say that you shouldn't over-index, like it in my opinion, over-indexes on trying to make it one sequentially readable block. I would not have given that constraint as an interviewer. I would say I would like you to, try to. We're hoping not to fragment it to a ludicrous extent, but if the chunk size of it on disk ends up being 100 megabytes at least, that's fine. One of the proper questions to ask if you're going to score well on this interview question are like, where does the data come from and what's it used for next, to establish, can we not just ask the database where we got it to give us them sorted already, and to establish that all of the records will in fact be used in their sorted order after the process is done. And it's not just that you're trying to find the bottom 100 or the top 100 or something, because you can obviously design an algorithm to select the bottom and top 100 that's much more efficient than sorting the whole thing, or potentially you can do that. And if you do conclude that the whole lot sorted is what is required, you should also establish, like, do we need the file to be sorted, or is it enough to create a separate index file that says that when you want the first one, it's at this place in the original file. When you want the second one, it's at this place in the original file. Because again, that could be implemented much more efficiently and allows for, if this is going to get resorted and resorted and resorted into different orderings, perhaps you can avoid repeating doing that work. Back to the algorithm that QWQ decided to come up with. What it wants to do is read 4 gigabyte chunks. So no, it's actually I've asked it this question 4 or 5 times. So sometimes it picks a chunk size of 4 gigabytes, sometimes 8 gigabytes, sometimes 5, never 10, because it assumes that 10 gigs is how much RAM the machine, the VM has, and so it can't actually use all of that for records. Again, that's something you should really establish, is that 10 gigs after the OS and all of that stuff has used some space, and so you really could use it all for records, or is the 10 gigs including some system buffers and whatever. So again, it's chosen to assume it includes that it needs to leave space for the operating system and some other junk in the 10 gigs. It's always chosen that. It logically divides the file into pieces that are 4, 5, or 8 gigs in size, reads each of those out of the original file. It then sorts it and writes it back to the storage where it got it from. Okay, so now you've got, if you had all kinds of random ordering, now you've got a sawtooth that's either 4 gigs wide teeth, or 8 gigs wide teeth, or 5 gigs wide teeth. The next thing it does is pairwise merge those sorted areas into a single area that's the next size up. And with the amount of RAM available and the chunk sizes and the amount of disk space available and the chunk sizes it's done, there's no particular problem merging 2 into 1 and either storing the output on the separate volume before copying it back over the original file and erasing the extra storage, or in some cases you can fit the first layer entirely in RAM. Doesn't really matter. But all of those strategies, irrespective of what chunk size you start, at some layer you get to a point where you cannot fit the merged content into memory. You can't fit it into the 20 gigs of free disk space that you have, and also you can't fit it into the combined 20 gigs free disk space and the 10-ish gigs of storage that you've got. And you also can't guarantee that the processing you've already done has freed up any space in the original file. So you have to, at that point, if you were actually specifying this algorithm, you'd have to say, okay, so what we're going to do is we'll merge 20 gigs of these two. When we're merging two 20 gigabyte chunks, we'll merge 20 gigs into the output file. And then what we'll do is we'll read bits from the first chunk and move them into the storage that's been vacated from the second chunk to make sure we've got 20 gigs contiguous of like reusable space. We'll copy the merged stuff back into there, and then we'll finish merging those, the upper halves of those two chunks into the output 20 gigs. And that, if you do that, you can get, that's a pretty simple algorithm to get you to where you've got two 40 gig chunks left. And now you have you can do the same thing again iteratively, but it becomes a really complicated keep track of pointers and actually keep reading, writing, moving stuff around in the original file to free up space to do the 240 gigs into the 80 gigs thing. But it can work. The problem is, the problem with the designs I got from QWQ is they all followed this shape, and they all were very carefully specified for the parts that are not difficult. So the original read blocks, sort them, write them out, was accurately specified to where a junior engineer or where just a programmer could take what was written there in the spec and implement it. And then the part where it was complicated, where you're trying to merge two larger chunks together into their own space, and it's not guaranteed that merge will happen in a way that the space will be available when you need it. That was hand waved. There was no description of, so you need to keep track of where those pointers are and then move data out of the way, or we just merge 20 gigs, then we'll move stuff around to make sure there's 20 gigs contiguous, and then we'll move it in. So it hadn't made the choice between, am I going to guarantee it by potentially wasting some time moving data around, or am I going to monitor the situation, and if it's needed, I will move data around, which is more efficient but more complicated. It hadn't made that decision. It didn't appear to have identified that decision needed to be made, and it certainly hadn't described how you would implement either thing. So in the sense of, did it come back with an engineered solution, it kind of looked like one, but the part that it's hand waved away, which is that merging two large blocks into their own storage area, is actually more complicated than the original problem I'd asked it to solve. It's created that data conflict and then hand waved it away as though like a programmer can just deal with this without having to give it any engineering thought. And that's for me where I thought it really fell down. Now, I also want to say, and I feel like this is quite important, I didn't just read these designs and go, you've left a hole here, I'm going to go and diss you on the internet about it. I said as directly as I would if someone were to give me their thing in a system design interview, or indeed in real life. I said to it, during your merging of these large chunks, there's a scenario where you don't have the output space you've assumed is there to write into, and you haven't explained how to deal with that. Explain that to me. And I tried that again multiple times with different phrasings to see if I could get the get QWQ to explain what should happen there, and peeking into its thinking process, which you can do with the LLM, or that particular kind of reasoning LLM. Peeking into that, it does appear to accept that there is a problem, but it wasn't able to explain what it would do. And I don't know if that's just because it's regurgitated pairwise merge sort from some technical papers, and it hasn't. Those didn't go into the buffer management and output space, management detail, or it hasn't memorized that in its training or whatever. But not only did it present a design that was incomplete and therefore wouldn't be implementable as written, it couldn't correct that when a experienced engineer pointed out, here is exactly where the hole is. What can you do about it? And I found that a little bit. I actually was surprised that it couldn't correct that, because it had done quite well, and the error that it's made is that it appears that it doesn't know what it can and can't hand wave away, and that's something that that's really often what separates a junior engineer from a senior engineer and a senior engineer from principal engineer is you have to know you're meant to know. As a junior engineer, you know you should know what you know, but you also need to be paying attention to what other junior engineers know and what they can do. And then, so that when you're a senior engineer, as you're giving work items to junior engineers, what you can hand wave away to a general junior engineer. So you shouldn't, as a senior engineer, design the parts that a junior engineer could do, because you're taking away satisfying work from them, and you're not being paid to do junior engineer work, you're being paid to do senior engineer work. And senior engineer work is taking a problem that can only be dealt with by a senior engineer, doing some small amount of it that is senior engineers only, and ending up with some pieces that can be done by junior engineers, and you give those out to junior engineers. In the case where you're in a hierarchical organization that works in that way, that's how you should behave. And the same applies at principal engineer level. Your job is not to solve the problem from here's the problem down to, and now it's completely solved, we just need someone to type it in. Your job is to do any kind of uniquely principal engineering stuff, find the chunks that can be delegated safely to senior engineers, and then ask them to do those parts, so that everyone learns, right, and everyone is involved in the process. That's how engineering in that kind of organization is meant to be done. But my point is that QWQ hasn't. It's read all of the internet and a bunch of computer science papers and whatever. It hasn't ever experienced being a junior engineer or being a programmer or being a senior engineer. And so it may have observed the behavior that what you do at the top of the engineering hierarchy is you solve the outline of the problem and then say, here are some bits where I'm just going to say, look, this is a senior engineer can solve this problem. I'm not going to write it down for them because that's wasting my time and theirs. And hand wave it away. And you don't hand wave away the parts that a senior engineer can't do, right? And the same, if you're a senior engineer, you hand wave away the parts a junior engineer could do, and you don't hand wave away the parts that the junior engineer can't do. And if you're a junior engineer asked for a design, you hand wave away anything that's like specific to typing it in part of programming, but you don't hand wave away anything else, because that's your level is the finest detail. It has to be completely thought through at that point, or the design isn't finished. But anyway, so QWQ has perhaps got the idea that it should leave some gaps, but it doesn't know what shape those gaps need to be. And in some cases, it's leaving gaps that it can't itself fill in, which is an interesting flaw. You would fail this as a system design question, like even if it had made the right assumptions about what the constraints are. So it would have failed my interview because it didn't ask any questions to establish what the constraints are. If we were in the world where I had given it the constraints that it's assumed existed, and then it gave me this design, it's got an immediate question mark because it's hand waved away a part of the problem that is harder than the original problem is actually. And then it's failed because it can't explain what goes in that hole. And that's the other trick with being a principal engineer, is you hand wave away these parts, but the price of it is if a senior engineer comes back to you and says, you gave me this with this hole in it and I'm having real trouble fixing it, you absolutely have to be able to explain to them, at least an approach that you can take, or you've hand waved away something that's, you've made a senior principal engineer sized hole and hand waved it away, which you can't do. You're only allowed to hand wave downwards, not upwards. If you find a problem you can't solve, then it's, fine to acknowledge that and say, well, look, I need help here, but it's not fine to pretend that you've solved the thing and hand wave it downwards. That's anyway, that's my thought on it. So I'm now going to pause and have a drink. The other question was, can an LLM be a good replacement for a programmer? Can it do that job? And for that, I need a specification that's complete engineering terms, so all of the algorithm is described and done so in sufficient detail that it just needs typing in a programming language. And then I give to the LLM that specification and say, implement this in some programming language and see what happens. Now, when I designed this series of experiments, I'd hoped that the LLMs, or one of them, would be able to give me a suitable specification for the problem, which was not the case for reasons we've discussed earlier. So I had to choose another. I chose to ask them to code a solution for the same kind of outline problem, but it was one that I'd specified rather than one that the LLM had come up with. I want to talk about how I used QWQ to help with that process. So one of the LLMs I asked to write the code was QWQ, and I gave it my first draft of the specification for how you should write the code. And then I watched what it was thinking in its sort of internal dialogue between its experts. And I could see that there was some confusion about a couple of the things I'd said. And so I just stopped it thinking, went and looked at my design document to see if I also agreed that I had written it in a way that was less clear than it could be. I acknowledged, in fact, that I had written it in a way that left significant ambiguity, and I could see why it was confused about what I'd meant. So I corrected my spec, tried again. I think I went through 2 or 3 loops of that before its first thinking, which is where it basically restates what it's got to do, but in its own words, matched up with what I thought what I had intended to specify, and then I let it generate. And it was that revised spec that I gave to all the other AI models. Now that tells me that I might, if I was still working as principal software engineer, I might find it useful to feed my design specifications into LLM and have it relay to me what it understands that to mean, so that if I have written it less clearly than I would have hoped, I have a chance to correct it. And I think it was useful for that process, and I think it would have been useful for that process if I was dealing with human engineers or human programmers to type in my code rather than LLM programmers. And so that's an example of like where I think it can accelerate the engineering process or improve the quality, or certainly improve the productivity. So quality per time should be increasable by using LLM in that way. Whether you want to use a reasoning model and peek into its thought process, or it would be enough to use a non-reasoning model, I actually don't know. I haven't done that experimentation. Anyway, so I asked a variety of LLMs to implement that spec. As I say, I looked only at the first few hundred tokens from QWQ during the spec development process. I hadn't tuned it to be something where it would produce correct code. I just made it so that when it restated what I'd asked, it matched what I thought I wanted. Okay, so QWQ produced the closest to what I had asked for of all of the systems. It made a couple of weird like typos, and in one case it assumed that a certain function exists when it actually doesn't exist at all. I was therefore not able to run it unmodified, but I was able to correct the spelling mistake myself pretty quickly, and I was able to correct the thinko that this function exists when it doesn't, myself again quite quickly. That was so I only had to make 2 lines of changes, and then to evaluate all of these, I did the minimal corrections I needed to do if there were any, ran the program, verified that it indeed would work when limited to the resources that are, the resource limits are the same: 10 gigs of RAM, 20 gigs free disk space, maximum 4 CPUs available. So I limited them all in that way, and then just timed how long they took to solve the problem. And the baseline for comparison is I did a naive implementation of the same algorithm myself as the programmer, just to see how it would go. Now, QWQ's code was the most similar to the code that I wrote of all of the LLMs that I tried. As I say, I needed to fix 2 things, both of which would have been compilation errors and all red underlines in the editor, so really obvious, and one of which was really obvious what the token should, what the function name should have been, and the other was much less obvious how to fix it. But because I had my head in the problem, having just programmed it myself, I was able to fix that very quickly. So now I could type in my version of it faster than QWQ running on my machine could generate the code for me. So if we were both starting at like the start of a workday, I wouldn't particularly gain from having QWQ do it. If I had nothing else to do, I wouldn't want to sit there watching it do nothing for 3 hours before it generates the code. But if I arrived at this at a relatively complicated design spec on Friday night and told it, generate this, turn up on Monday morning, I don't care if it's thought for 56 hours and then generated the code, it's still there when I'm looking at it. So it could be, QWQ could be useful to me as a code author, I felt, in the real world. So it stated the scenario constraints, stated the algorithm you should use to solve the problem, and then I said you're going to write it in C++23 and you're going to write it with Doxygen comments. Now, the two places where QWQ fell down in that code generation task were, I'd said you're going to sort it in parallel here, and QWQ said you can't sort it in parallel in in standard C++, is not available. It put that as an inline comment or as an explanation for why it had coded it the way it had. It's like, no, that's not true. C++ has had parallel execution for its standard sort routine since 2017, and it's still there in C++23. So don't know where you're telling me that it can't do it. Clearly can, and I'm using it in my implementation of the same algorithm, which is actually the only reason that my code is faster than QWQ's implementation of the same thing. Is I made use of the parallelism that we have, and they didn't. QWQ didn't. The other thing with QWQ, it didn't put the Doxygen comments in, and so in that sense, it failed to do what it had been asked to. So 5.4, and indeed all the other models I used, which were QWen 2.5 Coda and Gemma 3, all three of those failed the task because they did not follow the algorithm that I'd specified. So the algorithm I'd asked them to use, I'll briefly recap it, that the version they were given was, as I say, much more detailed. But the algorithm they were told to use is read 32K of records from random locations in the file, then sort those, then pick every 2048th, which is starting at 2048, then 4096, and so on, to get 15 split points. Then you're going to go through, then you're going to go to 8 gigs, the last 8 gigs of records, read them into memory, scan through them, writing out into, partition 0, partition 1, up to partition 15, depending on those split points that you found earlier, to make new files with such that everything in partition 0 is less than everything in partition 1, and so on and so forth. Then you'll use the truncate function to remove the last 8 gigs from the original source file. And then we go look at the new last 8 gigs, and we will partition that, appending it to the files we already created, and then drop it with truncate again, and just repeat that over and over until the original file is completely empty. And then what you do, you read partition 0, you sort it, you write that out to the result file, and you remove the partition 0 file. Then you go to partition 1, you sort it, you append that to the output file, and you remove partition 1 file, and so on. And now at the end, you have all of the files sorted. The one output file sorted, and there's no extra files on disk because you've deleted them all during processing. And so the critical things in that algorithm are you have to read from the end of the file, not the beginning, so that you can truncate it. And if you don't read from the end, then the truncate is going to throw away data you haven't looked at, which is unacceptable because you won't have every record that was present in the original file in your output file. Okay. If you don't do the truncate, then you don't free up that 8 gigs of disk space, and you will run out of disk space while creating the partitions. You'll be able to do 8 gigs, and then the next one, halfway through processing that, you'll run out of storage. You'll exhaust the drive. Now, all of the other... So QWQ did what I'd asked, modulo some typos. All of the others made typos of their own, and comparable numbers, or hallucinated entire families of functions that don't exist. So all of them needed at least as much fix-up work as the QWQ code, but the other three, which were 5.4, QN 2.5 coder, and Gemma 3, did not do the partitioning in the order I'd specified and did not truncate as they went, meaning that their programs just flat failed because of disk space exhaustion. They all read from the start of the file because that's more efficient. Well, yeah, but efficient only matters when it works. It's got to work first. And Gemma 3 in particular gave me put a sarcastic comment in of, I'm going to truncate this file, but it's not necessary for correctness. If you were a junior engineer and you wrote back, handed me that back as your homework, we're going to have a conversation about doing what you were implementing what you were asked to implement, and also if you're going to write sarcastic comments, you better make sure you're right every time, because you're just setting up you're setting up an adversarial situation there where you're right or the senior or principal engineer who designed the algorithm is right. Balance of probability is, firstly, the balance of probability is that they're more likely to be right than you are because they've got more experience, but just they're never going to be affronted if you ask a question of or say, it seems like it could be more efficient if we did it this way. Can you explain to me why that would or wouldn't work? And if you phrase it in that way, you have a chance for them to say, we just didn't think that, or we thought it was a bit too complicated, but as you've shown us, it can be done in the same level of simplicity. So good work, you've made the system more efficient, thank you. Or you get an explanation of why what you thought should work won't work, and you get to learn something. So phrasing it as a question while doing what you were asked to do is definitely a way forward. Phrasing it as a statement that what I've been asked to do is unnecessary, and not doing it and being wrong is a way to get yourself marked down as having an attitude problem and get on some kind. You'll be monitored to see if you're going to remain at that company. So anyway, I found that interesting that that only one, and unfortunately the slowest one, could implement the algorithm correctly. The others did do a better job of comments. They did correctly put Doxygen comments in. A lot of them had some really weird design decisions they'd made, though. So again, all three of them had... so part of the specification was there's this data type that represents a record, and all three of those others had decided that the size of the record needed to be a parameter to a function that was getting called for doing the sorting. But then inside the function, they were all mapping the storage just to the record thing, data structure. Now that means the record size parameter is pointless. That you're using, if you're using the record data type, you already know what size it is from the size of operator in C++ or in C, and you shouldn't accept any other statement of its size. I guess you could demand that the caller passes in what the record size is and then check that it matches what you think and say, hold on, we're in a weird world here where what I've been asked to sort doesn't match what I know how to sort. That would be a reasonable use for it. But they'd all mixed this usage of some places they're using the record size that's passed in, and some places they're using the record data type and its inherent size, and with no real thought, no consistency. It's possible to do those things in such a way that the record data type maps only to the first part of the record size, but they hadn't done that in a consistent, coherent way either. It was just straight, like, if it'd come back again, if that had come back from a junior engineer, I'd have said, I don't mind if you want to have the caller pass it in, and then you're going to verify that what they think the record size is and what your code knows the record size to be the same, because that does seem like something you might need to check and fail on if it's a mismatch. But I am not down with you using two different values for the size of the same thing and not even checking whether they are a match, and just YOLOing that is not acceptable. So the other thing to say, I gave them a set of outline coding standards, which were like, use standard functions where it makes appropriately, and I don't want to see operator new and operator delete getting used anywhere. Phi 4 used new and delete. Like, I explicitly told you not to. So I told it not to. It then used them and then told me in its comments about the code it had generated that it hadn't used them. No, you have. Anyway, so I found that an interesting hallucination that it had come up with. And then the other kind of common error was to try and use C++ IF streams and OF streams to do this problem. It's not a category of problem that you should be using streams with. It's a category of problems that you should be using POSIX file IO with. And yeah, you should write wrappers around read and write so that you can be sure you've read everything you're expecting to read and written everything you're expecting to write. But you shouldn't jump to streams, because streams mean you can't truncate files except if you've got their file name, which is not a stable token as a file descriptor, and it means you've got an extra layer of buffering that you're not controlling for. And for those reasons, again, I did the minimal corrections required to get them to compile and run, and then I allowed these guys all the disk space they wanted. Some of them were using up to 240 gigs for when they, way more than the limit of 100 that was meant to be there. I allowed that for the sake of getting a runtime length measurement. But 5.4, QN 2.5 coder and Gemma 3 were all slower. In some cases, much slower than either the QWQ implementation or my implementation. And in order to fix them to be algorithmically correct, I had to fix a bunch of stuff. So a lot of them had got confused between the number of splitters and the number of partitions that you end up with. You always end up with one more partition than the number of splitters you have, or you should. A bunch of them had got that ratio wrong. One of them thought they would have half as many splitters as partitions, which is not how it works. One of them thought it would have, I think two of them thought you'd have the same number. Again, only QWQ got that relationship correct. And one of them was opening and then closing the stream for the output file in the innermost loop, like open the partition in append mode, append the record, close it in the innermost loop, which is why it was the absolute slowest. I mean, it algorithmically, in a sense, is the same, but because of having to open that file and then write and then close, which causes a implicit flush, it just getting way slower than all the others. Anyway, so that's kind of the high level bit of my experience with using them as coders. The other thing I think is important to say, this is going to vary from person to person, but again, QWQ is the only one where the structure of the code was anything like how I would have done it. I could adapt to the structure of code that some of the others had come up with more easily than others, but they were all a bit different to how I would have thought you would want to structure this this piece of logic. So again, I think if I was going to use one of these as a coding assistant, I would want to find the one that writes in the style that is closest to what I would have written had I written it myself, and not writes in this foreign style that I don't, if it's not how I would do it, then my chance of being able to debug it and fix it when it needs fixing are decreased compared to where I'd like them to be. Anyway, I think that's all I want to say about AIs as engineers or AIs as programmers for now. I don't think I'm going to make another video about it. I may or may not continue trying to use these things to help my allowing them to assist my coding. I don't write as much code as I used to when I was fully employed, obviously. And it feels like, these feel to me like a tool where you really have to spend some time with it to understand where it can help, where it can't, and turn it on where it can help and turn it off where it isn't going to help you. And gaining that experience of when it helps, when it doesn't, is I just don't think I'm going to put the time into doing that right now. As usual, if you've got any questions, stick them in the comment section below or contact me directly. This episode's informed by some conversations I've had with some of you who are watching and listening, and so thank you for that. I'm considering doing a series on how to be an engineer from all my biased point of view about what that means, and I'd be interested if you think that's something that would be interesting to you. Like, would you watch it, would you not? I've leaked out quite a lot of what that bias is in this video, I think, talking about programmers, junior engineers, senior engineers, principal engineers. As usual, thank you for your time, thank you for your attention. Enjoy the rest of your day, rest of your week, and I will see you when I next record an episode. Well, when you next tune into it. You know how this works. Cheerio. Cheerio.